Okay, video on changing any probability question concerning any normal distribution to a question concerning the standard normal distribution. All right, so we talked about the standard normal distribution in the previous video, and we said that it was the only one we have a table for. So now when we're asked a question about any normal distribution, remember, we're going to draw the same bell curve for any normal distribution. Each of the distinct distributions are completely described by what their mean is and what the standard deviation is. All right, so remember, x is a random variable distributed in a normal distribution with a center or a mean and a standard deviation. Greek letters mu and sigma for the mean and standard deviation. We know that the mean is in the middle. The curve is symmetric. The total area under the curve is 1. So the idea is we're going to ask a question about any normal distribution. We'll call it x again, which we just did. We'll say, what's the probability that in this distribution that we get a value greater than some value or less than some value or between two values? Right? We'll just use the greater than as our example to work with. So the probability that in this distribution we get a value greater than x sub 1. So the area under the curve to the right of x sub 1. That would be the answer to our question. Well, we don't have a table for this distribution, so our task is to find the z value that cuts off the same area in the standard normal distribution to the right of it that matches the same area under the curve in the original normal distribution to the right of the number that we're interested in. So we're converting the x value in this distribution to a z value in our standard normal distribution. Right? So the task again, the area under the curve to the right of the value we're interested in this distribution, we're changing it to find the z such that the same area is going to be under the curve to the right of that z. And we do that by using this formula. Right? This is how we standardize an x value. We subtract the mean of the original distribution and we divide by the standard deviation. Okay, so for example, let's say we're given this normal distribution and we're asked to find the z value associated with an x value of 28. So we want to know what is the appropriate z to convert to for an x value of 28 in this distribution. Well, we know the mean, we know the standard deviation, so just using this formula. And let me just mention here kind of the meaning of the z value, or another something that to understand is once you get this z value, where 0 is in the middle, so when we convert this to a z value, we're going to get the number of standard deviations away from the center of the original distribution that this value is. Right? If the z value is positive, then we know the value we're looking at is to the right of center of the original distribution. If the z value is negative, then we know the original value is to the left of center in the original distribution. So when we look at 28 in this distribution, we see 28 minus the mean divided by the standard deviation gives us negative 2 over 4 or negative 0.5. So what that tells us is that 28 is below the mean, which we see, right? 28 is below the mean by half a standard deviation, right? Half of 4 is 2. 28 is 2 less than the mean in that original distribution. So that's what the z value tells you, right? And always round the z value to 2 decimals because that's the way the table is set up. Remember, the z to the 10th is on the left-hand column, and then the 100th digit is across the top. We'll look at that table in a minute. But that's the idea. We want to convert any probability question involving any normal distribution to a probability question involving the standard normal distribution so that we can look up that number in our tables. So let's look at a specific example here. So we're looking at a normal distribution here. So we're saying X is a random variable distributed in a normal distribution with a mean of 42 and a standard deviation of 7. So we'll do all three possible questions: less than a number, greater than a number, between two numbers, okay? So first, in this distribution, we want to know what's the probability that we get a value less than 40. All right, well, we change, this is an inequality, so whatever we do to one side, we have to do to the other side. So we're subtracting the mean and dividing by the standard deviation here. Subtracting the mean, dividing by the standard deviation. And we're doing the same thing on the other side. When we do it to the x, we subtract the mean, divide by the standard deviation, we get the z-value. Right? So you don't really need to show this in-between step. You can go straight from here to the z, but I just wanted to show you that, in fact, we are doing the same thing to both sides of the inequality. Subtracting the mean, dividing by the standard deviation to get our z-value, subtracting the mean, dividing by the standard deviation of 7, and we get -2/7. Put that into your calculator, round correctly, it comes out to like 0.285. 0.285 rounds up. Remember, 5 and up, you round up, 4 and below, you round down. So -0.285 rounds up to -0.29, or down in this case since we're on the negative side. But then we want to look that up in our table. So now we just go to our table, and remember our table is set up for probabilities less than a given z. So all we got to do is get our table up on the screen and look for that number of -0.29. Let's make this a little bigger. All right, so we go down to the negative page, -0.2 on the left-hand column, right? This is the z-values to a tenth, this column here. And then the 100th digit is across the top. So we're looking at the very last column over here, down at, let's put this over, here we go. -0.2, go over to the column 9, and we get our answer 0.3859 right here. And that's our answer. And we see, we looked that number up in the table, probability that z is less than -0.29 gave us our answer of 0.3859. Now again, give it a common sense check. Always give your answer a common sense check. We're looking at this question, and we're saying less than 40. Well, we know 40 is below the mean, right? So we know our z-value is going to be negative, or at least you should see that by now, right? Since 40 is below the mean, our z-value is going to be to the left of 0 in the standard normal distribution. And our probability to the left of a number that's to the left of center, we know is going to be less than 1/2, right? So that's kind of a check. If your answer comes out to be, 0.6 something, something went wrong, because 40 is below the center. So below 40 is going to be less than half of the distribution. So our answer makes sense. All right, so that's the less than. That's kind of the easiest one, because you just convert the 40 to a z, you look up that z, and you're done. When it's greater than, we have to use a little bit of logic, and there's two different ways to look at this. So I'm going to show you two different ways to answer the greater than question. So first step is the same, change the x to the z, change the x here, subtract the mean, divide by the standard deviation. In this case, we get -6/7, which again rounds carefully to -0.86. So we want the probability, or the area under the curve in a standard normal distribution that is to the right of this negative number. Okay, so again, we know since this is a negative number, it's going to be to the left of 0 in the standard normal. So the probability greater than that's got to be more than 1/2. Right? So just as a guide to what to expect. Now, two different ways to look at this. Since the table, our standard normal table, only gives us probabilities to the left of a number, we can use the idea of the complement, right? Because the value is either greater than this number or less than that number. right? This is the probability that z is less than negative 0.86. So these are complements. So remember, 1 minus the complement gives us the probability that we're looking for, right? The total area under the curve is 1. If we subtract all the area to the left of this number from the total area, then we're going to be left with our answer. And we have to look at less than probabilities because that's the way the table is set up. So if we use the idea of complement, total area of 1 minus the complement, we now just have to look up this number, negative 0.86, and we're going to hope to see 1949. Well, we're going to see it. I'm going to ruin the party here. But let's just look at that, negative 0.8, and over to the sixth column, we see the answer we're looking for. Well, that's not the answer. That's what we're subtracting from the total area of 1 to get our answer, right? This is the 06 column. Notice up here, and we go down to negative 0.08, and the 06 column. We subtract this probability from the total probability of 1, and we get our answer of 8051. So that's the complement approach to answering the greater than direction question. Or you can use the idea of symmetry. With the standard normal, we know 0 is right in the middle, right? So if we want the probability that z is greater than some number, we can take the probability that it's less than the negative of that number. Okay, let me draw a little picture here to hopefully show you what I mean. So when we were looking at the complement approach, we wanted the probability that z is greater than some. I'm just going to use any number here. So again, we'll just look at some number in the area to the right, or greater than that number. So we can take the total area of 1 and then subtract off the probability less than that number, and that's going to leave us with the area that we want. All right, so that's what we were doing here. Taking the total area of 1, total curve, and subtracting off the probability less than the number, because that's the way the table is set up, and that leaves us with the area that we want. All right, so that's the complement approach. 1 minus the complement, 1 minus the complement gives us our answer. Now another approach, using symmetry, and I'm just going to use a random z value. Now this only works for the standard normal, right? So once we get to the standard normal, we're looking up these probabilities. So let's say I want the probability greater than some number. All right, well, since I know that 0 is in the middle, the probability greater than this number is going to be the same as the probability less than the negative of that number. Right? Just think of any number, 2. Right? The probability greater than 2 is going to be the same as the probability less than negative 2, because 0 is in the middle and the curve is symmetric. All right? So that's this idea. Probability greater than a number, even if it's negative, you then just switch it to be less than the negative of that number. And you'll see we get the same answer when we look up that number in the table. So here again, now we're looking at positive 0.86. Here's positive 0.8. And there's the sixth column, and we see we get that same number. All right, so 2 different approaches when we're dealing with the greater than question. Use the idea of complements to get the answer, or you can use the idea of symmetry to get the answer. All right, and the third case, when we're talking about between 2 numbers and using this same normal distribution up here, I used the same number so we wouldn't have to recalculate. We've already gotten a z-score for 36. Z-score for 36 was negative 0.86. The 36 becomes a z of negative 0.86. The x value of 40 becomes a z-score of negative 0.29. So this question, the area between 36 and 40 in the original distribution is the same as the area between negative 0.86 and negative 0.09 in the standard normal distribution. And again, remember what the z-values tell us. Tells us that 36 is negative 0.86 standard deviations below the mean of the original distribution. 36 is negative 0.86 standard deviations below the mean of the original distribution. 40 is negative 0.29 standard deviations below the mean. Again, give it a common sense check. And yeah, 36 is 6 units below 42. The standard deviation is 7. So yeah, it's negative 0.86 standard deviations below the mean. And similarly here. All right, and now when we talk about areas between two numbers, we draw a little picture here. Okay, so we have our z distribution. Nice normal curve. I got a better marker somewhere. I really don't. Oh well. All right, so between two numbers, let's just call this z1 and z2, any two z values. We're looking for the area between those two numbers in the z distribution. So what we do is we take the probability below the larger number, all of this probability to the left, and then we subtract off the probability below the smaller number, and that leaves us with the area that we want. Right? So the area between two values, we take the probability less than the larger value, and we subtract off the probability less than the smaller number. We've already looked those numbers up in the table. Negative 0.29 gave us this number. Negative 0.86 gave us this number. We do the subtraction, and we come up with our answer of 0.191. All right, so that was a lot of information. Hopefully you soaked it in, and we'll see you next time.